Today we're going to do some new verifying trig identities problems using some of our other tips and tricks from our list. And the first one we're going to do is using factoring. So our first problem is cosine x minus cosine x times sine squared x equals cosine to the third x. So if you look over here, you'll see that both this term and this term both have cosine x. Therefore, we can factor out cosine x, which is the greatest common factor. Now, when you divide cosine x by cosine x, remember that you're really getting 1. And I know that some people will forget that and they won't write the 1 at all, and then they'll just have like negative sine squared x, but that's not true. It's 1 minus sine squared x, so it's important that you don't forget that. Now this might not look like there's anything you can do with it, but there is something else I want to tell you about our Pythagorean identities that you learned. So the most important one that you learned was this one. Sine squared x plus cosine squared x equals 1. Now, what I want you to do is find that in your notebook, wherever you wrote that, and we're going to write a different version of this underneath. So if you look here, we could subtract sine squared x to the other side, changing this Pythagorean identity to cosine squared x equals 1 minus sine squared x. Now, I know usually you are not allowed to manipulate both sides when we're verifying a trig identity, but in this case, this one case of this Pythagorean identity, you can change it around so that cosine squared x equals 1 minus sine squared x. Okay, so look here, 1 minus sine squared equals cosine squared. And look over here, what can we do with 1 minus sine squared x? We can replace it with cosine squared x because those are equal. And now I have this cosine x times cosine squared x, and of course that's cosine to the third x. And that's what I was trying to get anyway. So I'm done. So this over here is a very important version of the sine squared plus cosine squared equals 1 trig identity. And that comes up a lot. Okay, so now I have a similar one that I want you to try. I want you to try not to look at the one above, but if you have to, it is there. But try and see if you can remember what we did without looking, and see if you can replicate, not exactly, but similarly to what we did above. And I'll check back with you in a minute. Okay, so I see this sine x and sine x in both terms. I'm going to factor that out. Remember that dividing sine by sine gives us a 1, not a nothing. Okay, now I don't have 1 minus cosine squared up here, but couldn't I do the same thing with this light blue one? With sine squared x, couldn't I subtract cosine squared x to the other side and get this version of the identity. I mean, surely if I can do it the blue way, I can do it the purple way. So let's come down here. I have 1 minus cosine squared x. That equals sine squared x. That's times sine x, giving me sine to the third x. Okay. All right, now we're going to have a problem with some fractions. I know, your favorite. 1 plus sine theta, and remember theta is just another variable, it's just like an x. Won't always be an x. 1 plus sine theta divided by cosine theta equals secant theta plus tangent theta. So remember, you have to pick one side to play your trig games with. It can either be the left or it can be the right, but it can't be both. Okay, I'm going to take the left side, but in this particular case, you could actually take the right side. It wouldn't really make, wouldn't make much difference. But I'll just stick with the left. So what we can do here is divide this fraction into two fractions, because look over here at what I'm trying to simplify this to. Secant theta plus tangent theta is 2 terms. I don't have 2 terms over here. I need 2 terms. The only way that's going to happen is if I split this fraction up. So I'm going to divide the numerator, each term of the numerator, by the denominator. Okay, and some of you might be able to see we're like almost done. So what is 1 over cosine? Secant. And what's sine over cosine? Tangent. And I'm done. Look at that. Don't forget, your last line should be an equation with exactly the same thing on the left as it is on the right. You need to have this line here. It's in our rule list. You can't skip it. Stop trying to. I don't really care if you write the secant theta plus tangent theta at every step on the way down, but it's got to be at the beginning and it's got to be at the end, and no skipping steps. Okay, so I'm going to give you one to try. It's very similar to the one above. As I said before, try not to look at the one above. Try this on your own. See if you can remember what we did. But if not, then of course you can always go back up and look. There you go. So 1 plus cosine theta divided by sine theta equals cosecant theta plus cotangent theta. Okay, you try to figure it out. I'll be back. Okay, so I hope you've gotten somewhere. I'm going to split up this one big fraction into 2 smaller fractions. And remember that this is one of the tips on your list. So don't forget to be looking at those tips, especially if you're stuck and you don't know what to do. Remember what I said today, or, well, whenever the last time I saw you was, that it's better to get in the car and just start driving. You're never going to get anywhere if you don't leave the driveway. Even if you get lost, at least you've left. And there we go. Okay, now this next one that we're going to do is definitely longer. So you're just going to have to bear with me. Cosine x divided by 1 plus sine x plus 1 plus sine x over cosine x. And all that equals 2 secant x. You might not think that you can get all of this garbage to turn into 2 secant x, but in fact you can. So if you notice, 2 secant x, this is one term. This is one term. This is a disaster. But somehow I'm going to be able to turn these fractions into one term. But how am I going to get two fractions to be one term? Well, I'm going to have to put those fractions together. And these fractions would have to have a common denominator in order to put them together. And they don't have one. And they don't even have anything in common. So the denominator of the first one is 1 plus sine x. And the denominator of the second one is cosine x. So the first fraction, this one right here, is going to need a cosine x on the bottom and a cosine x on the top. We need a cosine x on the bottom so that there's a common denominator, and we have to put one on the top because that's the only way you're allowed to do it. This second fraction is going to need a 1 plus sine x on the bottom, and therefore it's going to need another one on the top, because the only way you're allowed to do this is if you multiply the top and bottom by the same thing, because that's just multiplying it by 1. Okay, so let's come down here and clean this up. Now, you might recall way back when, in the beginning of the year, when we did those big ugly fractions, do you remember that we never cleaned up the bottoms? We just left the denominators as they were. You know, I didn't distribute this cosine x in here. I just leave it. But the tops, you do have to put together. Now, this here, this is foiling. Okay, so don't kill the puppies. So that's going to be 1 plus sine x plus sine x plus sine squared x. And all that is over cosine x times 1 plus sine x. Kind of a mess. There we go. Now I can clean up this fraction quite a bit. I can take the two sine x's, I can add them together for a 2 sine x. So I'm going to do that right here. Going to leave the other stuff the same. And at the same time, I could add the tops of these two fractions together, sort of save me a little bit of writing. Let me get the denominator in here. Because that was the point of this anyway, was to put the tops of the two fractions together. So I can just sort of do that in one step. Don't skip too many steps, but this step's okay. You can do that. Okay, now take a look at this numerator. Do you see a cosine squared x? Do you see a sine squared x? It doesn't matter that they're not near each other. Sine x squared, nope, sine squared x plus cosine squared x equals what? That's right, it equals 1. So the cosine squared x plus the sine squared x equals 1. Plus, there's another one here. So again, you probably don't want to do that in one step actually, because you do kind of want to be clear that cosine squared x plus sine squared x equals 1. I'm going to change this a little bit. I'm going to cut this stuff out. I'm going to move this down. Oop, lost some parentheses. That was fun. Get you back up there. Not quite so far. Get you back up here. There we go. So if you have a sine squared and a cosine squared that you're going to say equals 1, this would be helpful. And that way I know that you know where the extra 1 came from. Okay, I'm going to continue with my same denominator. Cosine x times 1 plus sine x. Okay, So, of course, we can put these 2's together. For 2 plus 2 sine x. See, it's taken a while, isn't it? You need a lot of steps here. Over cosine x times 1 plus sine x. Now, this is another place where people tend to get stuck. But think about the factoring. I can take a 2 out of the top. And if I do that, I'm going to get 1 plus sine x. And then it matches the bottom. And then I can cancel stuff out. Woohoo! Look at that. Isn't that crazy? Look at that. All right. Now I'm almost done. I'm just left with 2 over cosine x. Remember that I wanted to get 2 secant x, but that's fine because 2 over cosine x equals 2 secant x. And I have done it. And I hope you have too. And now it's probably time to try some homework problems. And we can do some more examples the next time.